Hi, today we are looking at section 4.2, which deals with sine and cosine laws for obtuse triangles. Now, essentially, both laws work the same way as they did for acute triangles. So we have our sine law, which is A over sine A equals B over sine B equals C over sine C. Or we can also write that as sine of A over A equals sine of B over B equals sine of C over C. And our cosine law is C squared equals A squared plus B squared minus 2AB cos of C, where whatever we're solving for, that letter goes here, and the rest of the equations filled up with our other sides. So for the most part, these laws work the same way as they did for acute triangles. With sine law, there can be something known as ambiguous case of the sine law in which more than one possible triangle can be created, but we'll go through that in the next section of notes. So here's our first one. We have this triangle ABC, and we want to solve for angle A. So we're going to solve for this angle here. Now, the first step I always do when solving anything in a triangle is label all the sides, because currently we just have our angles labeled. So opposite capital A will be lowercase a. Opposite capital B is lowercase b. Opposite capital C is lowercase c. Now we have to figure out what law we can use to solve. So if I'm solving for an angle with cosine law, I need all three sides. I don't have that. With sine law, to solve for an angle, I need its opposite side, which I have, and then I need another angle and its opposite side, which I also have. So because I'm solving for an angle, I'll write the form of equation where I have sine in the numerator. So I have sine A over side length A is equal to sine of, we have our values for B, so sine of angle B over side length B. At this point, I want to get sine of A on its own, so I'll multiply both sides by side length A. So that gives me sine of angle A is equal to side length A sine of angle B over side length B. At this point, I'll start substituting values in. So I have sine of A is equal to 11. Sine of B, which is 129, over side length B, which is 33. So we'll enter this on our calculator. And that gives us sine of A is equal to 0.259. Now to get our A on its own, we have to take arcsine. So that's A is equal to, when your calculator is sine -1, of 0.259. And that gives us A is 15 degrees. Next, we're solving for side C. So once again, first thing I would do is label all my sides. So if this is angle C, this is side C. If this is angle B, this is side B. If this is angle A, this is side A. Now, if we're solving for side C, we do have an angle opposite, so that part of sine law works, but we don't have any other angles, so we can't use sine law. For cosine law, we have two sides and the angle between those sides, so we can use cosine law. So for cosine law, that'd be side C squared is equal to side B squared plus side A squared minus 2 times side B times side A times cos of C. Now it doesn't matter where I put that A and B. These could have been reversed, same as they could have been reversed here. It'll give us the same answer overall. So we have C squared is equal to 12 squared plus 13 squared minus 2 times 12 times 13 cos of 134. So we'll go through and start simplifying this. So 12 squared is 144. 13 squared is 169. And then we have negative 2 times 12 times 13 times cos of 134. That gives us positive 216.7. So we'll combine all these terms. And that gives us c squared is 529.7. Now we need c on its own, so we'll take the square root of both sides. So we get a side length of 23. So like I mentioned, sine law and cosine law work the same way for obtuse triangles as they did with acute triangles.